Okay, thank you and welcome to our third module of our intermediate training where we'll cover the rescue kit. As we mentioned before, the rescue kit in effect is a get out of jail free card in Monopoly terms. It's a way to undo mistakes that you may have made during your survey. You may have wired your product wrong. You may have not set the time properly on your instrument. You may have not configured your CTs correctly within your instrument, or have inverted a CT where the arrow is pointing instead of towards the source, towards the load, and a whole bunch of other issues. I'll preface our conversation about the rescue kit in saying that the rescue kit can't undo calculations that were done on the instrument. So if you've got a power number and a watts number or something that's been stored in your instruments database, like an HDPQ database or something, it can't change that. However, if there's voltage and current, you can rescale that voltage and current and then possibly have Dran-View recompute that for you. So let me demonstrate the capabilities of the rescue kit, and that's under the data tab. So I select data, and the rightmost one is rescue kit. These other two buttons here we'll cover in our advanced training next week on the 24th. So if I select rescue kit, it's going to ask you what site you want to apply that data to, or those changes to. You could, and the point being, you could have multiple sites open in Dran-View. I only have one, so it's going to ask you which one you want to apply these changes to. So it's really easy now. I select the default one. Now there's three options available in the rescue kit. The first one is correcting the timestamps. So this is valuable in a couple ways. As we said before, daylight savings time just happened last Sunday in the United States. I think Europe and the other parts of the world are in 2 weeks, or maybe a week and a half from now. So maybe you forgot to set up your daylight savings time. You forgot to check that option in the instrument or set your time ahead. So you can adjust by hours in that case. So I can make my adjustment. I select hours, and then I can advance it by an hour, take away an hour. Another application of this is we ship from the factory. When we test it, your instruments are probably set to the Eastern time zone where we're sitting. Maybe you're sitting in California and you want to subtract 3 hours, or you're in Europe, in Central Europe, and want to add 6 hours to our time zone. You can do that if you forgot to set those properly in your instruments when you configured them. Another option for the time calculations is if you have multiple instruments. Sometimes, in fact, quite frequently, multiple instruments are doing measurements. So there's oftentimes you want to align the time of those instruments. So you know you have an event on an instrument, you know one instrument has the time, you can adjust the time of another instrument either in microseconds, milliseconds, or seconds, or anything here to kind of line them up on top of each other. So you know for a fact that an event or disturbance or something recorded on one product, you can reference the second meter to look at that exact point of time and know that your times are synchronized, to know that they are maybe related to each other, these events, or maybe unrelated to each other. So that's kind of the power of that. So two main applications. One is to correct problems setting up your time. The second is to align the time of multiple, or data recorded from multiple instruments. That being said, real quick, our instruments offer GPS and Ntp time synchronization, which can do that at the instrument level. So if that was not done at the instrument level, this is a way to do that here. So secondly, you have the correction of the probe connections. So these are primarily the most important things that are used here. So if you've accidentally inverted a probe, so like as an example, let me just set this up just a little bit here. I'm going to cancel this out. I'm going to go to my waveforms over here, and I'm going to zoom in to just a few wave shapes. In fact, let me undo this just because it'll make it easy. Unzoom it. I'm going to go into my little sag that I have over here, just so we get something more interesting. Okay. So now I'm going to go open up my rescue kit again, data rescue kit, and I'm going to select correct probe connections. So I'll move this off so we can see over here. And let's say I accidentally flip the current probe. So my current probe, well, actually I'm looking voltage over here. So maybe I inverted the connection of my voltage on channel B. So if I click B, and B is the green one over here, if you look, and then I select OK, and I select rescue. you can see my BCT has now flipped. All right. If I go back and I go to rescue, or B voltage rather, and I flip B again, my B voltage, click rescue, it's going to flip back again now. So more appropriately, these are usually used for currents because those are more common to have a current connection reversed and flipped. So that's the power of the probe connections and the voltage connections. So you can invert voltage, you can invert current, again, primarily to undo wiring mistakes. These over here, these are kind of a little bit less powerful on the left, but if you set the wrong nominal voltage, you set the wrong nominal frequency, you have the ability to do that. And you could also change the way the totals are computed, again, or recomputed by Dran-View if you selected the wrong wiring configuration. So again, the footnote, as I said before, this cannot undo computations. Like in this case, total power, if it's done by the instrument, Dran-View can't undo that. This will, however, help Dran-View recompute that when you are maybe correcting that within Dran-View if you had a wiring issue in Dran-View. So last but not least, and this is a extremely common one, and this is the connection scale factor. So when you use our instruments, you select a CT. Very commonly, in fact, nearly 100% of the time, you are selecting a particular CT type. You may also be selecting a PT. So maybe you selected the wrong CT, or you forgot that you're connected to a PT, or for a CT, a current transformer, maybe you forgot that your 10 amp CT is actually connected to the secondary of a built-in 5 amp CT, and you needed to tell the instrument the scaling of both of those. So maybe a 3000 to 5 CT in addition to selecting, as an example, RTR 2510 in the instrument. So these are meant for cases where you had a big oops in the field, you forgot to configure the instrument correctly and account for the transducers or all the transducers in the measurement chain. So simply put, if like as an example, if I look at my voltage scale over here, you can see it's a scale from 0, and we're kind of covering up, and this one goes to about 150. So as an example, let's say I forgot I was on 100 times PT. And again, I'm just making this up right here. So 100 times for channel A, I click OK. I click rescue. You see now my scale is now 15,000. So it went from 150 volts to 15,000 volts because I've changed the magnitude, the scaling of this voltage. You can see I only did it from channel A because all B and C are now based on a 120 volt system that we had. So you can see how you can easily go in and you can rescue things like that. All right. You can also divide them back down again if you wish. So I multiplied by 100, I can now divide by 100 and go 0.001 or 0.01 maybe. So if I do that, if I did that math correctly, I do 0.01, rescue, I'm back down where I started again. So again, the rescue kit, the intent of that is to save you from problems that you may have had or operational or connection or setup problems with the instrument. To summarize, you can correct the timestamps. You can correct the probe connections, most powerfully invert voltage and current on an individual phase basis, and also correct the scale factors of your voltage and your current channels.